This video summarizes our ICRA paper, Safe Distributed Lane Change Maneuvers for Multiple Autonomous Vehicles using Buffered Input Cells. The paper studies distributed collision avoidance algorithm. The proposed algorithm is distributed, reactive, and works for high-order linear dynamic systems. We also demonstrate the performance of our algorithm in an autonomous lane change scenario. The approach we're using leverages the concept of Voronoi diagrams. We adapt the original Voronoi diagram to polygonal-shaped robots, create buffers, and project the buffered Voronoi cells into control input space to provide a set of control inputs, which guarantee collision-free maneuvers for multiple robots. The key assumptions we made are as follows. We assume the robot has linear system dynamics and no control constraints and strong controllability. Further, we assume all the robots show reciprocal behavior. We first introduced generalized buffered Voronoi diagrams. The original Voronoi diagram shown in the red animation are generated based on point robots. We compute the generalized Voronoi diagram for polygon-shaped robots. Voronoi boundaries are computed based on the closest points between neighboring vehicles. And then, we retract the boundaries of the cells by robot's geometry using Minkowski difference. The shaded regions are buffered Voronoi cells. Further, we propose buffered input cells, which maps the buffered Voronoi cells into control input space. Given system dynamics, the buffered input cells are computed as shown. We show that as long as control input of all the robots remain in their current buffer input cells, collision-free is guaranteed in next time step. The buffer input cells are updated with new robot positions at next time step. To demonstrate our algorithm, we use BIC as one layer in an autonomous lane change control. If the desired control input doesn't satisfy BIC constraints, we choose one control input closest to the desired one. In the first simulation, the blue and red vehicles want to swap lanes and are both using the proposed controllers. They successfully avoid a collision and proceed to lane change maneuvers. In the second simulation, the blue vehicle is controlled by a human driver who violates our reciprocal assumption during the lane change. However, there is still no collision in the simulation.